Okay, I'm going to do a video on question number 3 in your multiple choice review packet. There's been a lot of questions on this one, and I completely understand, so let's just do a quick talk through of it. First thing that I'm doing is I'm thinking about what do I know about, it's a pretty straightforward question in terms of what you're asked to do. You're asked to evaluate an integral, but at this point we have a lot of ways of thinking about an integral and what an integral means. So some thoughts that are coming to my head right now are an integral is area under a curve. So can I find the area under the curve? Well, the curve in this case is the function inside of the integral, and I don't know what that curve looks like, or I don't really want to think about that. That seems way too complicated right now, and I don't have a picture of it. So if I don't have a graph and it's not something I can easily picture being a line or something like that, then I'm going to move on to what other techniques do I have for evaluating integrals. So what's coming to my mind is fundamental theorem of calculus. Our original part gives us an evaluation method. To summarize my thinking, let's go back to fundamental theorem of calculus. Again, our first part, antiderivative evaluated at the upper limit minus antiderivative evaluated at the lower limit of integration. Just a quick reminder, I'm not plugging into this function here. I'm finding the antiderivative first. So then I'm looking at this function, and you're probably thinking, you want me to find the antiderivative of that function? What? That looks ridiculous. So let's remember that calculus is always easier when we do algebra first. I said this a whole bunch when we were doing derivatives, and I'm going to start saying it a whole bunch again now that we're going to look closer at antiderivatives. So what do I mean by that? I mean, if we do some algebra, this is going to turn into a pretty easy antiderivative for us. So what I'm going to do is I'm going to take that x squared over x squared minus 1 all over x, and I'm going to rewrite it as x squared over x minus 1 over x. Remember, we go backwards a lot in calculus. So if you look at this function or that combination of functions, and you say, what if I were to put those together and actually subtract them over one denominator, you would get right back to here. Okay, why am I separating them? Because now I'm going to be able to do some simplification. So x squared over x, I know you're seeing that the x squared in the top is going to cancel. Well, one of them is going to cancel with the x in the denominator. And that's going to get me to integral of x. X is right here. Integral of x minus 1 over x. So, oops. I shouldn't forget my limits of integration, so let's clean that up a little bit. I'm going to go from 1 to e, and I also should be careful about writing my dx. So I've got this sort of complicated function inside, but that's fine. 2 parts, I can handle that. So next thing I'm going to do is I'm going to look at, can I actually find the antiderivative? And if you want to, you could certainly rewrite this, and you could rewrite it in terms of 2 different integrals. I find it easier when I'm trying to evaluate it to keep it as 1, and then I can plug in both numbers. I'm not plugging into 4 different things. So just a personal preference. Okay, antiderivative, here we go. So I'm reversing x, and I know that I'm going to have to get an x squared. Derivative of x squared is 2x, but I want it to just be 1x. So to cancel out that 2 that I would end up with, if I take the derivative of this guy, I'm going to have to divide by 2 or multiply by 1/2, whichever way you like to think about it. So I think a lot of us like to do a 1/2 out front. And then the second piece here is interesting. The derivative or the antiderivative of 1 over x. If you try to make that a power, you would get and rewrite it as x to negative first. That's usually my thought. Then if I raise that by a power, I get x to the 0, and that's kind of a problem. So if you go back to your derivative rules, I know you'll remember it once I say it. The derivative of some function is 1 over x, and that's actually natural log of x. If that's not sounding familiar to you, you're going to have to review your derivative rules. Okay, so that's my antiderivative, and I'm evaluating that from 1 to e. So now I'm ready to evaluate it. And to evaluate it, I'm going to plug in both parts. I like to kind of generally set it up here and show myself that I'm going to rewrite this antiderivative twice and put in first e and then put in 1 and subtract the 2. So let's do that. And I'm getting 1/2 x squared minus natural log of x, and that x is my e. Plugging that in. And then I got to do it again, and I've got 1/2, again, x squared minus natural log of x, and this time plugging in my 1. And you still got a ways to go, because obviously that's not matching any of my answers, but we're very much on our way to getting this correct. So let's go ahead and keep simplifying this a bit. And if I simplify this, we're going to have to remember a little bit of pre-calculus here. Natural log of e is 1. How am I thinking about that? Well, I'm thinking e to some power equals e. I'm thinking in exponential form. That's just how I do it. And e to the first power is e. I'm going to jump over here. E to what power is 1? That would be 0. So I've simplified those. I don't think we can do much with this 1/2 e squared, so I'm going to leave that like that. And then I've got 1/2 1 squared, which is just a 1/2 here. And I've got minus quantity. Now it ends up that I don't have to worry about that, but just remember to distribute through your parentheses when necessary. So I'm ending up with 1/2 e squared minus 1 minus 1/2, which is actually minus a 1.5, or minus 3/2. And that, I believe, is matching up with one of our answer choices. So let's do a quick look back at the answer choices, and I'm getting e squared over 2 minus 3/2. That is 3/2. That is answer choice E. Hopefully that helps to walk through that question. Maybe you just got stuck at the very beginning with the algebra part, and then you were fine after that. But if you needed the whole thing, that should help you to make sense of that.